All right, we're a minute past, so I guess I'll get us started. Can everyone see my screen? I'll take the silence as a yes.
Yep. See it.
Great. All right, so thanks for coming. I know a lot of you. There are a few that may not be familiar with me, but my name is Andy. I'm a Cisco Solutions Engineer for Public Sector in Minnesota. Today's session is about securing your Catalyst network with wired 802.1x. And we're going to actually go over the switch configurations today as well, line by line. So that if you have a switch that you can SSH into today, a test switch, you can leave with the switches completed wired 802.1x configuration ready to go. So just to kick it off, a little bit about me. I'm from Wisconsin. Don't blame me. I'm a Packer fan. I also spent a decade in Chicago, and then I've been here in Minnesota for about a decade now, too. And I had a ton of careers over my life, but I had a late in life career change via Hennepin Tech, where I got my cybersecurity certificate and a CCNA. And then I cut my teeth managing Minnesota's largest fleet of connected vehicles for the Met Council. Those are the Metro Mobility buses. There were over 1,000 routers with DVR systems, payment systems, all that stuff. Married with pets, 1 dog, 3 cats, and I've been with Cisco going on 3 years, not quite. So, well, let's dive into the topic. So why do we need wired 802.1x? Port authentication with 802.1x and radius. It basically turns your wired network edge from like an open hallway into a locked door. The first thing we can do is stop anyone with a cable. So without 802.1x, any device that's plugged into an active jack can oftentimes get on the internal LAN. And this includes like visitors and contractors, but also rogue devices, bad actors, a pen tester if you're getting audited. And with 802.1x, the switch blocks normal traffic on the port until the device authenticates and the port is authorized. And this means that unknown or unmanaged devices, they never reach your production LAN, VLAN. The second thing that is of import with .1x is that identity and policy can be applied at the port. .1x allows you to tie this physical port to a user or a device identity, and not just a MAC address. We usually use MAC addresses with port security. That's different from port authentication. And then once we have this identity tied to the port, that can drive the policy, the identity can, which means we can apply different VLANs, we can apply ACLs or SGTs, security or scalable group tags for role-based access control for like staff or for students or for guests or for IoT. We can have all of those devices plug into the same jack and they'll receive their specific policy according to their identity as opposed to MAC address. The next thing is it benefits visibility and audits. Each port session is authenticated. And that means that you can see who is on which port with which IP and MAC address and at which time. And this greatly improves investigations and compliance reporting. There's central logging on an authentication server, and that provides a detailed record of how many access attempts people have had, failed logins, or any unusual behavior on your wired edge devices. And as a matter of fact, whenever I have a problem with authentication or connectivity within my home lab, my radius server, my authentication server, that's almost the first place I check every time. I use ICE. There are many, many different flavors of radius server, though. And another benefit of .1x is that you have a consistent security model. Most organizations are already using this technology for your wireless networks. By putting it on the wired, we can remove the gap where wireless is locked down and wired is wide open. It also utilizes a single framework called EAP, using EPOL, and that can scale across both media, wired and wireless. And what that does is it simplifies the architecture and it makes your zero trust at the edge story a lot cleaner for your auditors or for your leadership. And it reuses the same policies on your radius server, so you don't have to create individual policies for every authentication. And the last thing is it's scalable and it's a long-term fit. By this, I mean that .1x is vendor neutral, widely supported on switches, supported on endpoints, and it's designed to scale to large enterprises and service provider networks. And with that central policy control that's in your authentication server, that lets you evolve from just like having an allow and a deny to really more advanced features like posture checks and dynamic roles over time. And you don't have to reconfigure your port every time that you change the end user, it's just dynamic and automatically applied. So that's the basics of why we want to do wired. So let's kind of take a look at the how. These are the key components that exist within port authentication. Port authentication and wired 802.1x, they're kind of interchangeable as terms. The first component is on the left here. It's the supplicant. Now that's the client device that's requesting access. It's usually a computer in a wired situation. But if it was wireless 802.1x, it could be a tablet, it could be an iPad, etc. And this supplicant is what submits the credentials, like the username, password, and the device certificate. The next piece in the puzzle is the authenticator. This is the network switch or access point if you're doing wireless 802.1x. And the authenticator enforces the port policy, and it also relays the authentication messages between the authenticator and the authentication server. Then we have the authentication server. Typically, this is called a radius server, and it validates credentials and assigns VLANs or access rights. There are a lot of authentication servers. I use Identity Services Engine, which is a Cisco product, but there's HPE ClearPass, there's Fortinet, there's Network Policy Server in Windows Server. And almost always, these are connected to an IDP on the back end using a service account. So my Identity Services Engine has an Active Directory account that it can go ping my Active Directory, and that's how it verifies the data. And the beauty of being vendor agnostic is that you can have Cisco Catalyst switches and you can have a Windows NPS server. You could have Windows endpoints authenticating against the Cisco ICE server with even HPE switches in the middle. This technology is totally fluid and vendor agnostic. You can mix and match whatever pieces you want. So then there are two other components to wired 802.1x. And the first is on the front end here. They're the protocols. ePOL is what is used for the supplicant and the authenticator to communicate. And technically, ePOL is IEEE 802.1x. So when we say that, we're really talking about this protocol right here. ePOL stands for Extensible Authentication Protocol over LAN, and it's used to secure wired ports on switches. It blocks all traffic initially except for the authentication messages, and then it opens the ports only after successfully verifying against a radius server. ePOL is the transport, and you may have heard of EAP-TLS, you may have heard of PEEP, and you may have heard of TEEP. Those are the authentication methods that are passed within the ePOL packets. So it's a little confusing. ePOL is the transport that passes the packets. EAP-TLS, PEEP, and TEEP are the authentication methods within those packets. Now, this method is actually configured between the supplicant and the authentication server. Those are the two pieces that negotiate which method to use. Today, we're going to be using PEEP. PEEP is also referred to as username password. EAP-TLS is a more secure method because it uses username password and a device certificate. So that does both user authentication and device authentication. But today we're just going to focus on user authentication to fit in the time. So that leaves us one last component to .1x, and that's the radius protocol, which is over here, steps 4 through 7. Radius is a UDP-based AAA protocol. AAA means authentication, authorization, and accounting. And this centralizes the authentication and the policy enforcement by exchanging access request, challenge, and accept messages between the authenticator and the authentication server. That's what Radius does. It talks between these two devices. It passes information with things called Radius AV pairs, which has a value or a key and a value, and it passes those to the authenticator. And the switch takes that and it's able to apply policy based on those values. Radius requires a shared secret between these two devices because otherwise we don't have like a trust relationship built. And if you want to read more, it's defined in RFCs 2865 and 2866. So the traffic flow, let's just do one quick traffic flow through here. So the endpoint plugs into the switch. The endpoint will reach out with ePOL to the switch to say, hey, I'm here. The switch can also be configured to automatically request the credentials as soon as the port comes up, which is something we'll do. So once the endpoint says, I'm here, the switch says, hey, who are you? And then the endpoint says, I'm username and password, or I'm device certificate. The authenticator then takes those credentials and it forwards them onto the authentication server. The authentication server takes the credentials and checks with that database, that IDP, identity provider. This can be almost any identity provider. You may know Active Directory. It's a very common one. LDAP, but we also do cloud and SAML IDPs like Entra ID or Okta. The backend IDP could also be a token server like an RSA token. So once the credentials are validated on the backend with the IDP, the authentication server will top-down evaluate the identity and assign a policy. Then it will pass that policy back to the switch. The switch implements it and enforces it and basically authorizes the user. And that is wired port authentication, aka 802.1x. I'm going to pause for a second here. Do we have any questions around the protocols, the traffic flows?
Does it slow anything down?
No, it doesn't slow anything down. Well, there's delay in radius, of course, but it doesn't slow your regular traffic down. It does introduce the authentication process, which takes an amount of time. Okay. But once authenticated, traffic flows like normal. Doesn't slow anything.
And then does it get re-authenticated at any point, or just when you plug in?
Absolutely. We'll configure a periodic re-authentication so that the port does check that it's still the same device, it's still the same user.
Okay.
As we go through this, is there going to be a big difference between Radius and TACAX?
Well, Radius and TACAX, that's a good comment. TACAX is another authentication protocol that's in some ways better than Radius, and in other ways, it's more overhead than Radius. When we're talking about port authentication, we're usually using Radius. TACAX I use a lot with device authentication because TACAX will account for every command that's sent. It'll have an accounting of every single one of those, which can be a little bulky for something like user connectivity. So generally, TACAX is reserved for device authentication, whereas Radius is used for user authentication.
Okay, cool. Yeah, we're running TACAX here where I'm at. So
excellent. Yeah, and TACAX is the preferred protocol for a device admin because it separates out the authentication, the authorization, and the accounting all into separate messages. Radius combines authentication and authorization together over port 1812. It does the accounting over port 1813. Another thing about Radius is that the username is not obfuscated. It's not encrypted. The password is, but the username is clear text. So in some ways, it's not as secure, whereas all the communications within TACAX are encrypted.
Thank you.
My pleasure. All right, well, let's look at the configurations. Here's what we're going to do today. I mentioned that many of us are running .1x on wireless, and we already have an authentication server in our environment that responds to our Radius requests, so that's pretty much done. Configuring .1x on the switches, it's mostly the same steps as configuring .1x on your WLC for your WLANs. There are a few differences, but the first thing is there's a Radius server or servers. Many times there are servers because we want redundant authentication capabilities. The second thing is we have a set of AAA commands that tells the switch when and how to interact with the Radius servers. The third item is we want to enable .1x globally on the switch. It has to just be turned on. The fourth item is that we have a policy map. And this one can kind of confuse people, but it's really simpler than it looks. The policy map basically determines the authentication actions that should be taken. And the final thing in the configuration is a handful of interface commands to enable the .1x on the interface, apply the policy map on the interface, and set the host mode on the interface. Outside of the switch, the endpoint must be 802.1x capable to do .1x. We do have MAB fallback, which is a MAC authentication bypass for devices that can't do .1x. Like some printers can't do .1x or some IoT devices can't do .1x, but we still want to secure those. We would use MAB as a fallback authentication. Most OSs have built-in supplicants. Windows, Linux, Mac, they have built-in supplicants where EAP can be either configured or negotiated with the authentication server. And that brings us to the authentication server. That's the other piece that we need. We need a functioning Radius server. and it needs to have authentication and authorization rules that the endpoint credentials are then evaluated against. Once the endpoint evaluates those credentials, it'll assign it a policy and send that to the switch, and the switch applies it, and that's what controls the traffic. On the right, you can see the minimum commands required. These are pretty bare bones. First is to have your radius server. You give it a name, and then you assign it the IP address that it has and the ports that it's going to communicate over. The switch must know the shared secret for the radius server, and on the radius server, you have to configure that same shared secret for this specific switch. For the global AAA commands, this first one, that just enables AAA on the switch. It doesn't come enabled out of the box, so you just have to turn it on. The second one creates the group out of our radius servers. Again, the reason we want a group is because we want redundancy in our authentication so that we can go server to server to server in case one goes down. These next three lines, AAA authentication, authorization, and accounting, those are called method lists. And what a method list does is it takes the authentication type for .1x and it tells it where to look. It's going to look in the radius group. For any .1x authentications, hey, go check out this radius group. We give it a name too because we call on this auth list later in the interface configurations, or actually in the policy map. Same with the authorization. If we're authorizing network access, we give that list a name. This is created by you, unique to this switch. And then for this list, we tell it where to look. Look at our radius group for the authorization. And then for the accounting, we want to track any starts and stops of sessions, and we want to send it to that same group. So these are lists that are called upon later in the configuration. This number 3, .1x system auth control, that just turns it on the switch. It doesn't turn it on. It doesn't make the switch enforce. The interface configurations make the switch enforce. This just enables it as a feature on the switch. Any questions on the first 3 steps? We will go in and actually do them in a CLI too after I explain them. All right. So then steps 4 and 5. These are a little more confusing, but they're really not that bad. So step 4 is to create this policy map, which is applied to the interface. The policy map contains conditions that we match against. They're listed by these event words. The event is the condition. Session started, match all. So that means anytime a session starts, we match on this condition and we do the rules that follow. In these rules, we reference the authentication lists that we created above. And we say, retry it 3 times, 5 seconds each time. The next event that we want to match on is if the authentication fails. What do? Well, we want to terminate .1x on both. And then the final piece here that we match on is a violation. So anytime we have a violation, we want to do this action of restrict. Now, a violation would be, for example, when we put the interface configuration on, we can say how many users can authenticate on that port. Maybe we want 1 user at a time. If there's more than 1 user, it's a violation. Maybe we want 1 phone and 1 user. And if another phone shows up, it's a violation. So what action do we take? We restrict. Now, the word restrict is kind of deceiving. It just means log. There's shutdown, there's port bounce. We can do a bunch of different things in case we do have a violation. But these are really bare bones settings for this. If we wanted to have MAB fallback, let's say our .1x doesn't work and we want to use the MAC address of our printer in order to authenticate that printer, we could put a 20 right below this. Authenticate using MAB, AAA, AUC list with the list name in. And then the last piece of .1x is the interface configurations. And this is where it all comes together. Everything we did so far doesn't affect any traffic on the switch. It's just putting the pieces in place so that we can configure them on the interface. The interface does the enforcement. Within the interface, the first thing we want to do is enable periodic re-authentication. That's what this first line does. It says, hey, this is a feature that we're going to be using. The second line gives a timer for how frequently we want to re-authenticate. The third line, access session host mode. This determines how many users can connect. Single host, like I said, just lets 1 user authenticate. Multi-host requires the first user to authenticate, but everybody afterwards just gets free access. So I'd probably avoid multi-host. Multi-domain means you get one phone, you get one data user, one computer that's like connected after the phone. And then multi-auth, this would be a situation where a port may have a hub connected to it and you may have 5 different users there. It'll authenticate each one of those 5 users. And the next command, access session port control auto, that's the command that makes the switch initiate the ePOL conversation whenever the port comes up. So if we don't have this command, the switch won't initiate that upon the port turning up. The endpoint, the supplicant, that might initiate it first. So it still may work, but I almost always encourage this port control auto so that the switch sends that ePOL message. Then .1xPAE Authenticator. This is the command that turns this switch port into an authenticator when thinking about that supplicant authenticator authentication server relationship. Without this authenticator message, it won't act as an authenticator. The final command on here is to put that policy map. And the policy map tells the switch port what to do as an authenticator. We want to authenticate using .1x and this method list. And the method list, again, it points at our radius group. So basically, we're authenticating against our radius group. And those are the basic configurations for wired.1x. Once these interface configurations are on a port, only that port is doing this stuff. So we can test this. We can put steps 1 through 4 on your switch. It won't affect any traffic at all. Once we do step 5, it affects traffic on that one port. So it's a great thing that we can test on a test port. Another option we can do is called low impact mode, where we don't actually terminate if it fails. Low impact mode is a way of testing wired 802.1x without affecting your environment. If we took out that line that says 10 terminate .1x both, then when authentication failure happens, the port remains authorized because we haven't terminated the session. So there are ways of implementing wired 802.1x that are kind of stepwise. You know, we can start with the low impact mode, and then we can expand out. We can start with just a couple interfaces, and then we can expand out. We can start with just password, username, password, and then we can expand that out to MAB. Any questions on the configurations?
Andy, you might have mentioned this, and maybe I missed it, but when you have this configured, how long will that port stay authenticated? For example, like I have teachers that will sit at their desk and they will be hardwired into the network, but then they'll get up and move around the classroom, and so they'll disconnect and move to wireless. Are they going to have to reconnect and re-authenticate when they plug back into the wired network every time?
If they unplug and replug to the wired network, they will have to re-authenticate.
Okay.
Now, if they leave their laptop plugged into the wired network, then the re-authentication timer is determined by in two different places. We can set it here on the interface, and the interface will determine that I'm going to re-authenticate this user after every 3 hours or every 6 hours. It can also be configured within the ICE, within the radius server policy that's passed back to the authenticator. In your specific case, you have an authorization profile that might permit VLAN, your production VLAN. There's a checkbox there that says re-authenticate. You can put a time in there too, and then it'll re-authenticate at that time frame. The ICE or radius server assigned re-authentication time will override the existing switch configuration for re-authentication. Just like our radius server's VLAN assignment will override the existing VLAN assignment on the interface. So I'm sure you can see the benefit of this, where we can get different security groups assigned to an interface dynamically. We basically don't need VLANs configured on any interfaces because they can all be dynamically assigned by a radius server. Yeah. Any other questions before we dive into a demo? I will take the silence as acceptance. So if you brought your own SSH access to a switch, now is the time to log in. And I'll get mine, move mine over to the screen. All right. Can everyone see my CLI? Okay, thanks, Ben. Thanks for the thumbs up. All right, so we're basically going to go through that list of configurations. And I also have a document of just the configurations that I'll send to you and you can test out on your own. And I wrote mine up here. Now, I already have a Radius server on this. I'm using Radius for my device authentication, like we had talked about TACACS versus Radius. I'm using Radius for my device authentication right now. So the server already exists. I can't remake it, but I'll show it to you. Show run AAA. These are all my AAA commands that I have existing. I have a lot, but we're going to make new commands that we're going to apply. Here is my Radius server. It was pushed by Catalyst Center. If you do have Catalyst Center, super useful tool, allows you to push templates, push configurations to your switches, makes for consistent configuration across your environment. So this is the Radius server we're going to use. So step 1 is pretty much already done. Step 2 was to do the global AAA configurations. You know what, let me go back to that page and we can have those up while I do this. There we go. Let me pull this guy. We'll just make them a little smaller so that we can see. All right, there are the global Radius configurations. We have to be in configure mode. I already have it, AAA new model running, but it doesn't hurt to put it in again. Let's make this Radius group server Radius. We're going to call it Radius server group 01. And I'm going to put the server name, and that server name was dnac-radius_10.1.10.20. And then we want to get a source interface. I'm doing VLAN 21. That's my management VLAN here on the, oops, I forgot the dash, the hyphen. That's my management VLAN on this switch. And then we want to give it a dead time for the group. Dead time is important because there's something called critical VLAN, critical auth, which we'll get to after I finish the configurations we'll talk about. All right, so that was the Radius group all configured. Next up, let's configure our 3 method lists. So the first one, AAA, authentication.1x, we're going to give it a unique name to us. Let me see what I wrote down for my name. There it is. I use the name mlist, method list, authc, authentication, 1x. I like meaningful names in my configurations. And we're going to use the Radius group that we just created, group 01. Next up, we want our authorization command, AAA, authorization network, mlist. I'm giving it a unique name, authz network, so that I know it's specifically for this function. Group, Radius server, group 01. There we go. Next, I do the accounting method list. AAA, accounting, identity, unique name, mlist, account, ID. This one, we have to put the words start, stop in to indicate that we want to send a message to this Radius group every time a session starts or a session stops. So then we use group and we do Radius server group 01. All right. And the last piece is the dynamic author. So AAA server Radius dynamic author. And then I configure that client, my IP address for my Radius server. We need the Radius key for COA. And that's done too. So we just did steps 1 and 2. I'm going to exit this. And now let's configure enabling .1x on the switch. It just takes a .1x system-off-control, and it's turned on the switch. None of these did anything to traffic. They aren't used in anything yet. So let's get to that next. Our next piece is to configure the policy map that defines the authentication actions that we'll be taking. So let me grab that. All right, for the policy map, we want to type policy map type control subscriber, and then we give it a unique name for this policy map because it will be used to apply on an interface. I'm going to call it wired.1x. Case matters in these policy sets. Then we define the conditions that we want to match against. Event, session, started. I'm just going to make this a little bigger so it's easier to read. Match all. So this event captures every session start, and it will do these following rules every time a session is started. This line, 10 class always do until failure, just means that everybody hits it. Everybody's going to do this. You can set classes with class maps that identify specific traffic, and you could do different events, different rules for different classes, but in our deployment, we want to do all the same authentication, so we're going to do everybody, do until failure. And then we give the authentication rule, 10, authenticate using .1x, AAA, auth, C, list, and now we do our method list that we made. Does anyone remember what I called it? Mlist, auth C, 1x. We define the number of retries, 3, and the retry time, 5 seconds. All right, so that was the first condition. Let's do the second condition. That is event authentication failure match all. Again, we want a class always do until failure. So that means everybody hits it if you, there we go, spelled class wrong. So everybody, if they failed in authentication, they are going to do this next rule. And that rule is to terminate both, .1x both. By both, it means on the supplicant, and it means on the authentication server. We have one more event, and that event is the violation. Event, violation, match all. We put in the 10 class always do until failure, make sure everybody does it. And then what we're going to do is we're going to log it with restrict. But if you wanted to see the options, you can disable, notify, protect, replace, and restrict. All right, so that is all the policy map configurations. The last piece of this puzzle is to do the interface, put it on an interface. So let's take a look at interface 10 gigabit 1/0/19. We can see I have switch port access VLAN 22, switch port mode access. All of this stuff, that's of NetFlow. This is a Catalyst Center switch, so I'm passing a whole bunch of NetFlow back to Catalyst Center so I can see ABC and stuff. So you don't have to worry about any of that. It won't be on your switch unless you're using Catalyst Center. So let's apply the authentication onto the interface. The first thing that we did was enable authentication periodic. This is the re-authentication, oops. Authentication, oh, not in the interface, sorry. Int T 1/0/19, there we go. Authentication periodic. That just turns it on. Then we have to assign a timer for that. So authentication, if I can spell, timer, re-authenticate, we're going to do 3 minutes. Then we set the host mode, access session, host mode, single host. Again, if you're connected to a phone and a data line, you'd want to use multi-domain. If you had many users connecting to this one port, say through a hub or through some other mechanism, you'd want to use the multi-auth. Then access session port control auto. This is the command that initiates the ePOL conversation anytime the port comes up. .1x PAE authenticator. This turns the switch port into that authenticator role between the supplicant and the authentication server. And then service policy type control subscriber. And then we use that policy that we made. And I called it wired.1x. We're done. That's wired authentication on this port. So if I exit, there are some show commands we can do to take a look at who has authenticated. And some of those commands include show authentication sessions. I can see I have a laptop here. This is my test laptop. And this guy is plugged into port 21 right now, and it's unauthenticated. It failed its authentication. So I'm going to switch it to that new port that we just configured, port 19. And I can see on my endpoint, it prompted me for username password here because we're doing PEEP, just username password. So I'm going to do that. I'm going to put in a username. My user is CMS student. That's my Cleveland Middle School student user. And I'm going to put in their password, and I'm going to click OK. I have an IP config going. I don't see any IP address. I'm going to run it again. Now I see it's received a DHCP IP address. on the VLAN 22. So let's look at that show authentication sessions again. And now we see, here it is, the interface, the MAC address, the method. Domain means data or voice. So just FYI. And that it is authorized. Here's the session key. Let's look at the details of it though. If I do show authentication sessions interface 10.1/0/19 detail, now I see a whole bunch of information that I like. All right, so here is the command I just issued. So below that, I can see the IP address that they were given. I can see the username, that it's authorized, that the port is in single host mode. All great stuff. Down here, I see this SGT value. This is for microsegmentation. I'm just working on getting it deployed in my environment. This shows that it has an SGT tag of 16 on it. And at the bottom, we saw the method was .1x, and the state is auth-c success. Now, if I had MAB as a fallback on here, that method would show MAB instead if I had failed the authentication. So it's super easy. Once we have the bones of steps 1 through 4 in place, you can apply the interface configuration to all your interfaces. You can just stamp and repeat across your interfaces. Especially useful if you have templates through Catalyst Center or port profiles that you're using. You can just put this on every port that requires it. So any questions on the actual configuration?
Andy, I have a quick question. That was a Windows client, I think I couldn't quite see it in the image, but
Yep.
does that still require the service for the wired .1x service started to get that prompt, or does that start automatically from something?
Totally. You hit a nail on the head there. So let me show you about it. The endpoint was a Windows endpoint, and it does have to have 802.1x enabled on that NIC card. So here's a NIC. If I open the properties, this is a familiar page. Everybody's been here, right? This is how we manually set our IPv4. This authentication tab at the top, we have to have this enabled. I'd also mentioned how the endpoint negotiates the inner EAP method with the authentication server. Here's where we configure the endpoint's inner EAP method. And then the authentication server would have a list of EAP methods as well, and they would negotiate and match. PEEP is username, password. EAP TLS is username, password, and device certificate. There's also TEEP. There's a few others as well. Some are more secure than others. This is usually pushed with a GPO. So whether you're using Intune or it used to be SCCM, I suppose, you could just push this out to all your endpoints so that they have the right authentication method that you want. Part of this maturing of our network security posture, we could start with EAP because it's easy. We just did it right now in less than 15 minutes. And then we could graduate up to EAP TLS, where we actually have device authentication in addition to user authentication. Any other questions on this?
So yes. So can you cache the username password? How does the supplicant work?
100%. We can cache the username password. Shoot, I just closed it. Let me open it back up. Yep. Here, properties, authentication, advanced settings. No, maybe it's the settings, not advanced settings. One of these two. Specify authentication mode, user authentication, save credentials. And now I can put my credential in, and it will use the same credential every time.
Okay. Do you know if you can configure that via group policy, or will the user have to do that, take those steps?
You can configure it with group policy. And there's another setting that says always use the user that's currently logged into the machine. That's generally what the option I would use.
Okay. Yep.
Yeah, here it is. Remember my credentials. And it will, yeah, you can select that it uses the user that's logged into the device at the time.
Got it. Kind of like wireless when it, same thing.
Yeah.
Okay. And have you ever used certs, the TEEP for this?
I haven't done the TEEP yet, but I'd like to. I'd like to test it out. What are you, because you use TEEP, right?
Yeah, we use TEEP on wireless, so I don't think it'd be a big bridge to get this working on wired, correct?
Right. Let's open this up in the authentication. We can select TEEP right there. So you'd want to make sure that the GPO pushes this authentication method to your endpoints.
Sure.
And then you'd also want to validate on the authentication server side that TEEP is an approved protocol.
Sure.
Can you see my ICE server right now?
Yep.
Okay, great. Here's this is an example of a Radius server, identity services engine, but there are many out there and they all work. HPEs, ClearPass, Fortinac, NPS, they all work. And they all basically have policy sets that are evaluated down. If you match a condition, you move on to the authentication and the authorization. Within this allowed protocols, that's where we would define what EAP methods we use. So if we wanted to look at that, I can look here, my results. Allowed protocols, default network access, and here we can see what protocols we are allowing. So you'd want to make sure TEEP is checked as well. There it is, allow TEEP. And another fun fact is that for EAP TLS and TEEP, those are device and user authentications. The device authentication always goes first. And then through that device authentication, there's a secure tunnel on the inside that the user authentication happens, the username, password. Yeah, and also in your Radius server, I had mentioned, best place to go for troubleshooting stuff. I can see my authentication right here in my Radius server. CMS student, that was the guy I used. I can scroll to the right and I can look at the policy that he hit, the authorization that they received, the profile, permit access. This profile could have been, well, students belong in VLAN 33. I'm assigning you the VLAN 33 authorization profile, and we could push that VLAN down. Then instead of getting this subnet that was configured in the interface itself, which I think we saw, let's see, show run int t1/0/19. I got this subnet right now. But if ICE pushes a different subnet, it'll overwrite this switch configuration, and it'll give me that new subnet. Another fun troubleshooting command. So let's go to those a little bit. There we go. All right, do you see my switch configurations? Here we go. All right, these are some commands that I use pretty regularly in troubleshooting Radius and Wired 802.1x. This one specifically, test, AAA, group Radius, user, password, new code. That'll show me the policies that get assigned without actually having to log in.
Any like gotchas or common pitfalls that people run into when they're trying to implement this? Or
Yeah, there are a couple. No private VLANs. They just don't work with the dynamic port authentication. Private VLANs are a way of micro-segmentation within a VLAN. It's basically a VLAN in a VLAN. Another one is don't tag your native traffic. If you have .1q tag VLAN native, that means that your native traffic will have tags on it. And that doesn't work with the port authentication. Separate voice and data VLANs. If you're in host mode or multi-domain, those will get you. And then this one especially, a lot of people try to combine port security with port authentication, and it just doesn't work. And some other tips to help make sure that we have a good deployment. Make sure your timestamps are on. This is a configuration that's right at the top when you do show run. We want to make sure that we have millisecond timestamps. MAB is great for your printers, your IoT devices, anything that can't authenticate, doesn't have a supplicant. This one gets people. If it got me and Steve, the supplicant and the authentication server the EAP method didn't match, and that caused us a headache for a little bit of time. Another tip is to have this critical auth enabled and have the guest fallback enabled. And that means if the authentication does fail, you'll still have access. It'll be on the guest VLAN or the critical VLAN, but it won't completely break everything. Starting in low impact mode before enforcing. Basically in the policy map, don't have that terminate line. Instead of terminate, have a line that says authorize. And then everybody, even if they fail authentication, they'll still have access. And you'll see the authentication failure in your Radius server. Yeah, and then just know the rollback commands. You can disable .1x globally like that. Clear your sessions and you're good.
So with that okay, I do have a question. So when when a user logs into the machine for the first time, they won't have certs on that box, and they get it from the certificate authority. So how would you have to put a method in beforehand or something, or how would that work? I wonder.
So I know there is a workaround for that. Let me take that as a takeaway. Let's see. User connects first, then cert is pushed. Let me research that a little bit, and then I'll shoot an answer to the whole group. How is this evaluated?
We have the same problem down in the sheriff's office with their guys too. Same thing with wireless. So that'd be great.
Yeah, I think we could accomplish it in the rules of the Radius server itself, where we would have a rule it would match that only requires the username password, and then from that point they could get on.
Sure.
And we could re-authenticate and run through the rules, and then they would hit the double authentication with device and user. And we could have limited network access if they only use the username password, and then full network access if they use the certificate with the username password.
Yeah, well, sounds good.
I'll look into the details and I'll get those sent out to everybody. Well, we are coming up on the end. Take my contact information if you don't have it already. Shoot me any questions. You want help doing this? I'm here to help you. I'll sit on a session with you. Ask Steve.
Yeah, absolutely. Very good. Thank you, Andy. We appreciate it.
It's my pleasure. If anything comes up, reach out. I'm here for you. Just a minute away. See ya.
Thanks, Andy.